Thanks for sticking around so late in the afternoon. We're here to present the work, How Architects Learn, Training of a Daylight Simulation Tool in Architectural Design Practice. And my name is Toivo Säwén. I'm a PhD candidate at Chalmers, working with lifecycle building performance.
And my name is Markus Gustafsson, and I'm an architect and an engineer working at Kaminsky Arkitektur.
So we'd like to start off by describing the problem with building performance analysis in the design process. And specifically in this project, we'll be looking at how architects can utilize daylight analysis tools. And we all know that daylight access in buildings is important for several reasons, but mostly for the well-being of the building residents. And this is, of course, very interesting in architecture because architects are largely responsible for determining some of the design parameters that affect the daylight performance. However, the complexity of the design projects that we have means that it's hard to keep track of the daylight throughout the building and make sure that it's functional for the entire building. And then what's growing in use in this last few decades is the use of quantitative tools, which can help understand if the daylight is acceptable for a given design. And then the question becomes how these tools can come in to inform the decision-making during the design process.
What we mostly see in the current design practice is that the use of quantitative tools is to validate the design once it's already been completed. This can be in order to see if legal requirements are being met or if an environmental certificate can be applied to the building. This means that the tools are not used to improve the design or the selected design or to select design alternatives that improve the chances of fulfilling the requirements. The problem we see with most tools developed today is that they have not been developed with the mindset of and fail to develop with this mindset and fail to solve the problems that architects are facing in practice. So what we wanted to do is to apply a practice-based perspective to see what happens when a tool enters practice and an architect starts using it. And this is based on the understanding that architectural practice, like most of the AEC industry, is a very social environment where people learn from each other and knowledge grow throughout the organization. By looking at these social processes and learning activities in particular, we wanted to see what happens we wanted to see what is needed for a tool to be adopted by the practitioners. And to do this, we carried out a case study in a mid-sized architectural company in Sweden. And we investigated various learning activities and wanted to figure out how they impacted acceptance of the tool among the practitioners. The tool is a daylight analysis tool, and it's built in Grasshopper and takes geometry from Rhino or Revit or CAD or SketchUp and transform it into an analysis model. And the model is set up using Ladybug tools, which allows simulating through the use of ray tracing. And finally, the results are presented in the Rhino interface, so the design can be adapted based on the results. And to follow the learning process, we conducted the 3 experiments to see their impact. And the experiments were each learning activities with different target groups and scope. The first one was a presentation conducted for the whole office. Then it was a series of seminars, which were conducted with a smaller group of employees. that got training using the tool together on sample projects. And then it was one-to-one sessions that were held on within real projects. Following these activities, questionnaires were sent out to the participants to understand how their perception changed. And we also conducted interviews with employees throughout the organization hierarchy to triangulate the survey results. And we were inspired by the technology acceptance model to analyze the collected response to the questionnaires and interviews. And the model postulates that the success of a given technology is based on its perceived ease of use and perceived usefulness. These labels became useful to organize and analyze the findings of our study.
And what we found when we analyzed these different activities is that they had very different impacts on the perceptions of these architects. First of all, the office presentation, where all of the employees were present, it was very successful in improving the motivations of the architect to work with daylight, and also improved the trust in the tool. And it improved the general knowledge from a low level, but didn't affect the knowledge of the specific tool that much. And the more focused seminar course was didn't really change the motivation of the use of the tool, but it really improved the knowledge of actually using it. And finally, the one-to-one training was most important in terms of improving the trust in the tool, that you could really use it and trust the results. And finally, the knowledge of the tool itself. And then the interviews showed us that there are very different needs from different levels in the office hierarchy. So on the top level at the office management, the most important usefulness was to provide a service offering to the clients, whereas the ease of use was improved by the ability of the tool to communicate the results to the client. The responsible architect, who was responsible for developing the project, needed to see credible results and trust in that the tool provided something that is actually correct. And they also wanted the users of the tool to be able to learn the tool quickly so that they can start working and not spend much time in the training. The project architect, who might be the one who actually operates the tool, they wanted to see the ability to benchmark results against, for instance, the regulations or the certification schemes that's used. And they also wanted to see little time consumption, because it's one of many tasks they have to carry out, and they needed a tool to give results quickly and model quickly. The junior architect talked about being able to use the tool to communicate within the project and using the tool directly in discussions with colleagues. But they felt they needed support when stuck, so that an important ease of use factor is the ability for someone to help out using the tool. And finally, the support staff, who are not architects at all, but support the operations, they wanted to see a robustness within the company so that several users are available and not only one person has the knowledge to use the tool. And that means that they need to understand the competence that is available so that they can guide, when people ask questions, to the right personnel in the organization. So to summarize, our main two findings is that we really saw that the combination of learning activities is beneficial to improve the perceived usefulness and the perceived ease of use of the daylight tool. And then we also saw from our interviews that practitioners in all levels of the office hierarchy have very different needs, so we need to consider not only the tool user, but everyone needs to be involved for the tool integration to be successful. And of course, this comes with some limitations, including the fact that we only looked at one tool in one company, so we need to look at companies of different scales in different locations and so on. But we believe this perspective and this way of testing was very useful to these findings. And we welcome your questions and comments on our presentation. Thanks.